density, and rarefactions are the region of low density, low pressure. Okay. Now, with every wave, two terms are basically oscillated to all kinds of waves. Number one, frequency. Number two, time period. Actually, these two quantities are related to all kinds of repeated motions. जहां पे भी कोई चीज repeat हो रही होगी, बार बार periodically अपने आप को repeat करती होगी, तो उस चीज की हमेशा एक frequency भी होगी और time period भी होगा. Time period, frequency, two things are related to all kinds of repeated things. Whatever is repeating again and again, it will definitely have a frequency and it will also have a time period. Now, what is frequency? Very basic definition is it is number divided by time. And the question should be number of what? If it is number divided by time, then number of what? Here is a list of what it can be the number of. Frequency can be number of waves. It can be number of crust and trough for the transverse wave. It can be compressions and rarefactions for longitudinal wave. It can also be the oscillations, number of oscillations for something which is vibrating. It can also be lap of a car in a racing game. आप लोगों को पता हो कि जो car racings होती हैं, the drivers are not supposed to move along the track once. They are supposed to lap again and again. Observing a racing car going around a lap again and again, we can find out the frequency of that car as well, like how many laps it complete in 1 hour or okay. Now, तो एक बात याद रखें, जो भी चीज रिपीट हो रही है तो उसकी फ्रीक्वेंसी जरूर होगी. अच्छा, जो चीज रिपीट हो रही है तो उसकी फ्रीक्वेंसी के साथ एक और चीज भी लाजमी होती है और उसको हम कहते हैं टाइम पीरियड. व्हाट इज मेंट बाय टाइम पीरियड? अगर कोई चीज बार बार हो रही है तो क्या ये बड़ी बेसिक इंफॉर्मेशन नहीं है? लाइक somebody wants to know कि how long does it take to happen once? If something is happening over and over again, we would like to know how long does it take to happen once. That is a very basic information, and that information is called time period. So how do we find time period? Time period is time that something takes to happen divided by number of time it happens. So frequency and time period, frequency है number divided by time, time period है time divided by number. इस वजह से ना अक्सर हम लोगों को ऐसे लगता है कि ये कोई फॉर्मूला है, बट एक्चुअली दिस इज बिकॉज ऑफ द डेफिनेशन ऑफ वन. फ्रीक्वेंसी इज रेसिप्रोकल ऑफ टाइम पीरियड एंड टाइम पीरियड इज रेसिप्रोकल ऑफ फ्रीक्वेंसी. Time period is 1 over f, f is 1 over t, and it has ft equals to 1. Now, एक बड़ी ही important definition of period. One other way of remembering what time period is. Time period is time that wave take to travel exactly one wavelength in the forward direction. देखें, वेव को एक वेवलेंथ ले जाने के लिए जो टाइम चाहिए, how long does a wave take to travel exactly one wavelength forward is known as time period. And time period is also the time that particles of the medium take to complete one oscillation. So keep in mind, these two definitions are about to become very important for you because this will help you to find out waves speed. Okay, speed of wave find करने के लिए हम लोग इन दो definitions को बहुत जल्दी से use करने वाले हैं. Now, this is a diagrammatic representation representation of what I just said. There is a particle and there is a wave. What happens to the particle when wave passes through it? ये ऊपर से नीचे diagrams बनी हुई हैं. T equal to 0 is the first diagram. After 1 by 8 of the time period, after 2 by 8 of a time period, after 3 by 8 of time period, 4 by 8 of time period, which is also half of the time period as well, 5 by 8, 6 by 8, 7 by 8, and see one complete wave through the system. In one time period. Look. Okay. How much wave has gone forward in this time? How much wave has gone forward? Answer is exactly one wavelength. Time did it take? Answer is one time period. How many oscillations particle has complete? Particle has completed one oscillation. So इसका मतलब ये तीनों टाइम सेम होते हैं. टाइम पीरियड भी वही टाइम होता है. Time that wave takes to travel one wavelength and time that particle takes to complete one oscillation. All these three times are exactly same. Now, okay, now. Speed of wave. What is the formula for speed of anything? Speed is distance divided by time. Now, when distance is exactly one wavelength, how much time does anything takes to travel one wavelength? Answer is one time period. Oh, if distance is a wavelength, the time taken to travel one wavelength will be one time period. That means speed of wave will be wavelength divided by time period. Speed of wave is wavelength divided by time period. So this is a very famous, very important formula that speed equals to wavelength divided by time, and not any ordinary time. It will be time period. No. We already know 1 over t is f. So we can replace, just 1 second. No. V equals to lambda f. So a very, very famous formula for speed of wave. V equals to lambda. V equals to f lambda. This is a famous formula for speed of wave. तो जरूरी नहीं है v equals to f lambda यूज करें हम लोग. Can also use lambda divided by time period. It depends on the data that is given in the question. If the data is given for wave, okay, it totally depends on the data that is given. If in the question the data is given for wavelength and time period, we can use wavelength divided by time period to find velocity or speed of wave. And if frequency and lambda is given, we can also use this one. Now, what is wavelength? A very basic definition of wavelength is that it is the distance between two consecutive crusts for transverse wave. Can be distance between two consecutive compressions for longitudinal wave. Lambda is also the distance that wave is supposed to travel in one time period, or while the particles of the medium complete one oscillation. So one lambda is a distance that wave travels in one time period. Wavelength is also the distance between two consecutive in-phase particles of a progressive wave. Now, this is the syllabus content that we need to know, that what is the perimeter of the syllabus that we are supposed to cover in AS waves talk. तो ये हम लोग करेंगे जब तक हम ये यहाँ पे जब हम कर लेंगे तो फिर हम एक टिक एंड क्रॉस सेशन करेंगे जिसमें हम देखेंगे कि हमने कौन कौन से टॉपिक या पार्ट्स कर लिए और कौन कौन से हमने फिर करने हैं, तो हम सिलेबस भी हम डिस्कस करते रहेंगे साथ साथ. अच्छा, what is Doppler's effect? Now, must have heard of that. When source or the receiver, they start moving with respect to one another, what happens is that the frequency that receiver receives becomes different than the frequency that actually produced by the source. Remember, again, if source or receiver if you can see the screen, yes, in the center is a source, a koi speaker hai producing sound waves, and those sound waves are going in all directions away from the source. Can you see the screen? Yes, sir. Okay. In the center is a source, A and B are two receivers. If source is producing a wave of frequency F, frequency received by A will be F, frequency received by B will be F. The wavelength that A receives will be lambda, wavelength that B receives will also be lambda. There will be no effect, no difference in frequency or wavelength or speed of wave that A and B receive. Sounds will be equally loud and equally everything. Only difference will be A will be there will be actually no difference in any aspect. Only difference will be that A is on one side and the other side. So recording in progress. Okay, now A and B will receive the same frequency. But what if source starts to move towards right? What happens if source starts to move towards right? In that case, look, if source is moving to the right, A and B are still at the same distance from the source. The distance of A and B is same. Okay. So what happens to the wavelength that A receives? What happens to the frequency? Okay. The problems is with the internet, not these days. Uh, this looks better now. If A and B are stationary, so the source is moving towards A. I hope you can see in the what happened to the wavelength that A receives. You can see that the wavefront goes, it means a wavelength for A has shrink. But what happened to wavelength that B is receiving? Wavelength for B has expanded. So wavelength for A has shrinked, wavelength has expanded. If there is no effect on the speed of the wave, how do you think this change of wavelength will affect the change of frequency? Remember, V equals to F lambda. What is F equals to? V divided by lambda. So it means lambda. Okay. Just one second. Let the screen come on. A and B, they both are stationary. So move current towards A. Wavelength that A receives, wavelength of A has wavelength for A has increased, wavelength for B has increased. And if you remember, V equals to F lambda and F equals to V over lambda. Okay. Now, okay. So if V equals to F lambda, F equals to V over lambda. That means F is inversely proportional to lambda. When F and lambda are inversely proportional, it means where the frequency, where the wavelength has decreased, frequency must increase. So A will be getting a frequency which is more than frequency actually produced by S. For example, if S is producing frequency F naught, A is getting a frequency FA and B is getting a frequency FB. The frequency of A will be frequency more than what actually produced by source. जब भी कोई सोर्स ऑफ वेव करीब आ रहा होता है ना किसी चीज के अप्रोच कर रहा होता तो रिसीवर एक्चुअली प्रोड्यूस फ्रीक्वेंसी से ज्यादा फ्रीक्वेंसी रिसीव करता लेकिन अगर किसी पॉइंट से सोर्स दूर जा रहा होता है तो वो कम फ्रीक्वेंसी रिसीव करता जिस तरह इन दिस केस यू कैन सी के सोर्स जो है वो ए के पास आ रहा है तो ए की फ्रीक्वेंसी इंक्रीज हो जाएगी और बी से दूर जा रहा है तो बी के लिए फ्रीक्वेंसी डिक्रीज हो जाएगी सो ये सारा हमने यहां पे लिखा हुआ है source is moving towards A, so speed of wave stays same. A gets smaller wavelength than actually produced by the source, and A gets more frequency than actually produced by the source. So इसका ये मतलब है कहने का कि frequency of A is more than frequency actually produced by source. What about B? B से वो ऑब्जेक्ट दूर जा रहा है बी से अगर दूर जा रहा है तो इसका मतलब है कि स्पीड तो सेम होती है बी गेट्स लॉन्गर वेवलेंथ देन एक्चुअली प्रोड्यूस्ड बाय द सोर्स एंड बी गेट्स लेसर फ्रीक्वेंसी देन एक्चुअली प्रोड्यूस्ड बाय द सोर्स इसका मतलब है फ्रीक्वेंसी ऑफ बी इज लेस देन व्हाट एक्चुअली प्रोड्यूस्ड बाय द सोर्स फ्रीक्वेंसी ऑफ बी विल बी लेस देन फ्रीक्वेंसी ऑफ सोर्स ये दो इक्वेशंस हैं फॉर source approaching रिसीवर, अगर सोर्स जो है वो रिसीवर के पास आ रहा हो तो फ्रीक्वेंसी जो सी है वो ज्यादा हो जाती है। तो उसको कैलकुलेट करने का फॉर्मूला है सी ओवर सी माइनस वी इंटू एफ नॉट। और इफ source is receding away, if source is going away from the receiver, in that case frequency received by the receiver will be less than actually produced by the source। तो उसका फॉर्मूला ये है। अब इसमें आप सोचेंगे कि what is represented by FB, FA, F naught, C and V? So here's a key. C means speed of wave, V means speed of the source with respect to receiver. F naught is frequency actually produced by the source. FA means frequency of receiver received if source is approaching it. And FB means frequency received if source is receding away. अगर सोर्स जो है ना वो रिसीवर से दूर जा रहा हो तो फिर जो फ्रीक्वेंसी रिसीव करेगा दैट विल बी एफ बी, और अगर पास आ रहा हो तो एफ ए। ठीक है, नाउ this is how it is provided in the data booklet, C over C plus minus V into F। जो डाटा बुकलेट है ना उसमें दोनों फॉर्मूलाज ओवरलैप करके लिखे हुए हैं, प्लस और माइनस। यू हैव टू डिसाइड बाय योरसेल्फ that whether you have to use C plus V or C minus V. Look, if you use C minus V, it means the denominator becomes smaller than the numerator. And whenever there is a smaller denominator, you get a bigger fraction. C divided by less than C will always result as something more than 1. और जब कोई more than 1 will multiply with F naught, you will get an answer which will be more than F naught. जब आप F naught से कोई चीज मल्टीप्लाई करेंगे which is more than 1, you will definitely get an answer which is more than F naught. Similarly, if something is receding away, frequency of the receiver should be less than actually produced by the source. In that case, we use C over C plus V. C over C plus V. What happens in this case? C plus V is definitely more than C. अब आप किसी भी नंबर को उससे बड़े नंबर से डिवाइड करके देखें, the answer will definitely be less than 1. And if you multiply any number with less than 1, you get a smaller number. So whatever you multiply over here as F naught, the answer will be less than F naught because C over C plus V is less than 1. Very basic maths. But if you cannot remember that kind of mathematical form, then you have to just remember that in case of approach, it is C over C minus V. And in case of getting away, it is C over C plus V. This effect of change of frequency with respect when source is moving with respect to receiver is called Doppler's effect. Okay, let's solve a question for Doppler's effect. Okay. Here's a question. State what is meant by Doppler's effect. So what do you mean when you say Doppler's effect? When source or receiver move with respect to one another, the frequency that receiver receives is different than the frequency which is actually produced by the source. This phenomenon is called Doppler's effect.
सर आप एक दफा दोबारा समझा सकते हैं?
You mean Doppler's effect?
Yes.
Okay. For example, if you're standing on a roadside, but you're not looking at the road, can you differentiate between the car that is approaching from the car that is going away? Just by hearing the sound of the car. For example, if when car is coming towards you, you will be getting sound like
That increases and so it decreases.
Why can we differentiate between them? Like, how do we know whether car is coming closer or it is getting away?
By the sound.
The quality of the sound changes, the frequency changes. Whenever frequency change, अगर source move करे या receiver move करे, उनके move करने की वजह से अगर frequency change हो, this change of frequency is called Doppler's effect.
Okay, sir.
You just read this thing.
Yes, sir.
When source or the receiver move with respect to one another, the frequency that receiver receives is different from that actually produced. This phenomenon is called Doppler's effect.
Sir. Thank you.
Okay, good. No problem. You're welcome. Now, here is a question. Read question carefully. This acts as a mark where there is a stationary observer. Okay. There is a child on a merry-go-round. ये एक झूले के ऊपर बैठा हुआ है child, और it is spinning. So sometimes, as shown in P, the child is moving towards the observer, and after some time, the child will be moving away from the observer. At P, child moves towards observer. Child moves away from observer. Does this make sense? ये एक प्लेटफॉर्म है which is moving in a circular path. इसके ऊपर एक बच्चा है पोजीशन P पे. वो बच्चा इसके ऊपर ऐसे करके घूम रहा है continuously. तो जब वो P पोजीशन पे है, which is the lowermost position, for the distant observer, the child will be moving closer to the observer. At this instant, at instant P, child is practically moving towards the observer. But at position Q, child is moving away from the observer. अब हम इस चीज को देखते हैं, इसमें क्वेश्चन में क्या पूछा उसने. A child sits on a rotating horizontal platform in a playground. The child moves with a constant speed along a circular path, as illustrated over here. The observer is standing at a long distance away from the child. During one particular revolution, the child, moving at speed of 7.5 meters per second, starts blowing a whistle at point P and stops blowing it at point Q. Okay, so he has a whistle in his hand, the child, and the child blows it when starts blowing it when he is on P and quits blowing it when it gets to Q. The child is moving with a speed of 7.5 meters per second. The observer is at rest. Okay. Now, the whistle emits a sound of frequency 950 hertz. The speed of the sound is 330 meters per second. Determine the maximum frequency of the observer. So first of all, decide at what time, at position, not time, at what position observer will receive maximum frequency when child is at P, or when child is at Q, or at any other position. In what position distance observer is supposed to receive maximum frequency, at P or at Q? Anyone? Listen, when you look at P position, child is moving towards the observer. So it is a case of approach. When you observe the same child at Q, child is moving away from the observer. So it is a case of departure or moving away or receding away. So at what position you think distant observer should receive maximum frequency? Anyone? No? I hope you remember that when source is moving closer, the frequency increases. When source is moving away, frequency decreases. So at me, observer gets maximum frequency. Observer gets least frequency. Now, maximum frequency, that will be speed of sound divided by C minus V into F naught. Okay, hurry, everybody, just try to calculate the maximum possible frequency. Similarly, the lowest possible frequency will be C over C plus V into F naught. In these formulas, C means speed of wave, V means speed of the source, F naught means the frequency that is actually produced by the source. Hurry up, calculate your maximum